Hello everyone. Today I explain the hashing or graphs. Come to the introduction. We focus on advantages structures like hashing or and graphs and their real life applications. What is hashing? Hashing is a data structure is a technique from storing and data using a hash table. It involves mapping keys to specific indexes in an array using a hashing function, aiming to distribute keys uniformly and minimize collisions. This approach allows from constant time over edge case complexity for intersection, deletions, and searching, making it highly efficient from large data structures. More details explanations in the hashing function. A mathematical function that takes a key, examples a string, number or object, has input and production and index. A numerical values has output. A function that maps keys to index should be fast and uniformly distribute keys. Hash table. Hash An arrays are a similar data structures where data is stored based on the index generated by the hash function. Key, key value pairs. Data is stored as key value pairs in a hash table where the key is used to determine the index and the value is the actual data stored at that index. Advantages of hashing. It is used from comparing two files from equality calculated as value of these files help compare documents word to word opening. Hash values can identify difference in files even when an file is designed in a manner to dissolve change in file size. Disadvantages of hashing. Multiple keys can hash to the same index leading to collisions. This requires additional machines like changing or opening addressing to handle function. Next point is the order of elements in a hash table is not predictable as it depends on the hash function and potential collisions. This can be a disadvantage is maintaining a specific order in circular. Uses of hashing. Hashing is used in many areas of computers science, including data retrieval, password storage, and data integrated checks. It's practically useful in data structures like hash tables for fast data retrieval. Collision of handle. Take news, changing, linear probing, quadratic probing, double hashing. First one is changing. Changing is a collision resolution technique in hash table. When a collision occurs, two keys that has to the same index. It research through the hash table for the next available empty slot. If it is occupied to the process continues until an empty slot is found. It is a changing. Linear probing. Linear probing uses a simple storage to resolve collisions. When a collision happens, instead of replacing the extended value, it checks the next available slot in the hash table. Is called linear probing. Quadratic probing. Quadratic probing is a collision resolution technique in hash table where when a collision occurs, the algorithm research from an empty slot by adding uses of quadratic polymer polynomial to the original hash index. It is a quadratic probing. Double hashing. Double hashing is a probing method with works according to the constant multiple of another hashing function. Both hash function must has the same type of keys. Is called double hashing. Changing in hashing. Each area index points to the linked list handle collisions. Open addressing. All elements are stored in the hash table itself. Uses probing to resolve collisions. Hash table use cases. Symbol tables in compilers, cases, databases, password verifications. Next topic, what is graph? Graph is a data structure. A graph is a way to represent a relationship between objects. It consists of nodes, also called vertices, and edges connecting their nodes. Graphs are used to model various real world such as social networks, transportation network, and computer networks. A, a graph is a collection of nodes, vertices connected by edges. Graph representation. Advantages matrix is a graph that represented the connections between nodes in a graph by using and ones where 0 indicates no edges and 1 indicates an edges. It is an alternative to an Edensy list from representing relationship is computer science. Advantages list. It is a common way to represent graphs, particularly pairs graphs where each vertex is stored a list or arrays. For list, advertise vertices of edges. Graph travelers techniques. There are two types. Breadth first search, depth first search. First type is breadth first search. What is breadth first search? It is a graph traveler algorithm that explores a graph or tree level by level. It starts as a design node and visiting all its immediately neighbors before moving on to the next level of nodes. Bedford search it is particularly useful for finding the shortest path in an graph. Visits nodes layer by layer, ideal for shortest path in unweighted graphs. Second type is depth first search. Depth first search is an algorithm from traveling as searching through graph or tree data structures. It explores as far as possible along each branch before backtracking. Depth first search is often implemented using recursive array storage, and it is used in various applications like finding spamming trees and solving matrix. Goes deep before backtracking, useful from connectivity and cycle deletions. Graph applications. Many types of graph applications. There are four types: social network, web crawlers, navigation systems, network routing. First one is social networks. Social network is a data structure. Graphs are used to model and analyze the relationship between individuals. Users are representing as nodes and connections are intersections like friendship or followings are representing as edges and analysis. This allows for is writes into network structures, involves and community format. Next, web crawls. Web crawls is a graph data structures are used to representing the relationship between web pages. With each page has a vertices and hyperlinks has edges. Algorithm like depth first search and then used to travelers with graph visiting pages systematically. Navigation systems. Graphs is data structures are used to model and representing navigation network such as road network where locations are nodes and roads are edges. Graphs can also represent another network like structures, social networks or computer networks. Network roasting. Network routing graphs has a fundamental data structure play a circular role in network roasting by modeling the connections and relationship between device and paths. Comparisons tree versus graphs. Trees are special graphs. No cycle in trees. Singular root node. Next slide is real world data structures uses. Operating system. Scheduling sequence. Compilation. Stacks. Hash table. Networks. Graphs. Real world data structures uses. There are three types: operating systems, compilers, networks. Operating system scheduling queries, compilers, stacks, hash table, networks, graphs, Choosing the right data structures based on types of operations, memory availability, performance requirements. Common interview questions. Implement hashing table. Depth first search versus depth first search. Delete cycling graphs. Open addressing versus changing. Reversing checklist. Hashing basis. Graph travelers. Applications in real world systems. Conclusion. Yours completed the day 5 journey through data structures. Keep practice to master this concept. Thanks everyone.